We begin with a core premise. Cognition is not a spontaneous event. It is a system. The common perception of thinking is something random is an error in user understanding. The primary issue we will analyze is the absence of an operational system, not a deficit in raw intelligence.
This leads to the central question: why are your results inconsistent? The answer is that these outputs are not random. They are data points, indicators of a flawed cognitive process. Contradictory decisions are simply a symptom of system instability.
The error, then, is not in the operator. It is in the process. What we call confusion is simply unstructured cognition. System failure originates from the absence of a repeatable process for handling information. It is a system error, not an operator error.
Now, let's move into Section 1, the illusion of thinking. We're going to deconstruct this illusion. It's important to understand that just because your brain is active, it doesn't mean you're engaged in controlled thought. In fact, most of what we call thinking is actually something else entirely.
Here is the critical distinction: reaction versus thinking. Our default mode is reaction. It's an automatic, very low-effort response built on mental shortcuts or heuristics. True structured thinking, on the other hand, is a delayed, high-effort, and controlled process. The key takeaway is this: by default, our brain will always choose reaction.
So why do we operate this way? First, this reaction default is a conditioned state. Our educational systems typically reinforce getting the right answer, not developing the right process. And second, the brain's own architecture defaults to energy-saving shortcuts. It's built for efficiency. Without deliberate, explicit programming, a structured thinking system simply is not built.
This brings us to Section 2, the cognitive system deconstructed. The solution to unstructured reaction is a formal cognitive system. We will now analyze its 5 critical stages: input, process, reason, output, and feedback. The integrity of the entire system depends on each one of these stages.
I will address the first stage, input. The system is initiated here. This stage is about the precise definition of the problem. Its function is to set clear operational boundaries. Any vague or poorly defined input will compromise the entire system stability right from the very beginning.
I will now address the process stage. Here, the defined input is deconstructed into its fundamental components. Variables are identified, and the relationships between them are mapped out. This stage carries the highest cognitive cost because this is where the mental structure is actually built.
I will address the reason stage. In this phase, logic is applied to the components that were just structured. Cause and effect relationships are established, and crucially, internal consistency is verified. This is the mechanism that transforms raw process data into a structured logical understanding.
I will address the final 2 stages, beginning with output. The conclusion or solution is generated here. It is important to understand that this result is purely a function of the preceding stages. The reliability of the output depends entirely on the integrity of the input, process, and reason stages.
Finally, the feedback loop is initiated. The output is evaluated against external data to detect errors and identify misalignments. This is what enables system self-correction. Without this feedback loop, the system cannot learn and improvement ceases.
Now for Section 3, common system failures. A system analysis will always reveal potential failure points. Unstructured thinking is the direct result of skipping or corrupting these stages. We will now analyze the single most common point of system collapse. And here it is. The primary failure pattern is that the processing stage is skipped entirely. When faced with a high cognitive load, the brain's default is to take a shortcut, a heuristic. This bypasses all the hard work of analysis and jumps directly from input to output.
This collapse of the system into just input and output corrupts the entire sequence. See, without a processing layer, there's no structure for the reason stage to act upon. The output you get isn't a calculated result, it's just an estimation based on a shortcut. This is not thinking, this is reaction.
Moving to Section 4, structured versus unstructured output. The consequences of system failure become very clear when we compare the outputs. And the difference we see isn't just about getting a better answer. It's a qualitative difference, a different kind of answer altogether.
Let's look at them side by side. Unstructured thinking operates on undefined inputs. It's influenced by emotional variables, and it produces inconsistent outputs. Structured thinking, in contrast, requires defined inputs, uses sequential processing, demands logical consistency, and therefore generates predictable outputs.
The conclusion here is direct and unavoidable. Random thinking will always equal random results. Structured thinking leads to predictable outcomes. It's that simple. Inconsistency isn't a bug you can fix later. It is a core feature of a broken system.
Finally, Section 5, System Applications and Limitations. It's crucial to analyze both where this system can be applied and where its limits are. This system is a tool for managing a process. It is not a machine for generating absolute truth.
So where does this apply in the real world? Well, in learning, it shifts your focus from just memorizing facts to building conceptual models. In decision-making, it replaces gut-feeling impulse with methodical evaluation. And in the age of AI, it frames AI correctly, as a powerful source of input, not as a final authority on output. But again, we must define the system's boundaries. This system will not eliminate cognitive bias. It does not remove uncertainty from the information you use. Its sole function is to increase the reliability and consistency of your process. It does not and cannot guarantee correctness. Which leads us to the final analysis, and a question for you. What system are you running? Because in the end, the structure of your process determines the structure of your output. The most important variable isn't whether you are thinking or not, but which cognitive system is actually in operation.